on proportional relationships. In today's lesson, we will look at equations and learn how to determine whether an equation represents a proportional relationship or not. You've done this with tables already. Today we're going to do it with equations. So to recall, the constant of proportionality is k here, represented by k, and you can isolate k by dividing both sides by x. And we'll get y over x equals k, and that's our constant of proportionality. And we will use this during today's lesson. Y over x equals k, proportionality. So let's look at different types of equations to see if they represent a proportional relationship. So let's start with this one, y equals 4 plus x. So let's substitute a few numbers for x. So 4 plus x, 4 plus 2 is 6. So y over x, which is k, y over x is 6 over 2, which is 3. So now for the next row, should also have a k, a constant of proportionality of 3. So let's see if it does. For the next row, we say y equals 4 plus 3, because we have 3 here. So 4 plus 3 is 7. And y over x is 7 over 3, which is not equal to 3 in the first row. So these are not equivalent ratios. So there's no unit rate, no constant of proportionality. It is not a proportional relationship, not proportional. So 4 plus x, y equals 4 plus x is not proportional. So let's look at another one. Y equals 4 times x. So let's substitute some numbers here. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. And now y divided by x, 8 divided by 2 is 4. 12 divided by 3 is 4. 16 divided by 4 is 4. 20 divided by 5 is 4. So all of the ratios are equivalent. They're all the very same. So the constant of proportionality is 4, and it is a proportional relationship. I'm going to say yes. So here let's look at 4 over x. So 4 divided by 2 is 2. 4 divided by 3 is 4 over 3. 4 divided by 4 is 1. 4 divided by 5 is 4 over 5. I'm substituting the numbers in here. So for example, the last one I said 4 divided by 5. That's where I got that from. And now let's divide that by, let's divide y by x. So 2 over 2 is 1. 4 over 3 is 4 over 9. I can do the math out here at the side. 4 over 3 divided by 3 is the same as 4 over 3 times 1/3, which is 4 over 9. So that's a different ratio, a different constant of proportionality to what we have in the first row here. So it is not an equivalent ratio. There is no constant of proportionality, and it is not a proportional relationship. Y equals x over 4. So let's put in some numbers here. Y equals x over 4. Y is equal to 2 over 4, which is 1/2. 3 over 4, 4, I'm going to say 1/2 up here. 4 over 4 is 1, and 5 over 4. And then y over x. So 1/2 divided by 2 times 1/2 is 1/4. 3/4 divided by 3, the same as 3/4 times 1/3, is 1/4. So 1, y divided by x, 1 divided by 4 is 1/4. This is looking like it's going to be proportional. Let's do the last one. 5/4 times 1/5, and these numbers cancel out, and so we get 1/4. So all of the ratios are equivalent. They're all the same, 1/4. So the constant of proportionality is 1/4, and yes, it is a proportional relationship. Let's look at 4 to the power of x. So 4 to the power of 2, 4 to the power of 2 is 4 squared is 16. 4 to the power of 3 is 4 16, 4 16, 64. Oh, I forgot to do y over x here on the first row. So 16 divided by 2, which is x, is 8. So 64 divided by 3 is 3, 20, 60, 21.3, which is a different ratio to what we have in the first row here. 21.3 is not equivalent to 8. So I'm not even going to do the calculations for the next 2 rows. I don't need to. If any of the y over x values are not equivalent, then there is no constant of proportionality, and it is not a proportional relationship. And there's one more example here, x to the power of 4. So 2 to the power of 4, 2 2 is 4, 2 4 is 8, 2 8 is 16. Oops. So 16 divided by 2 is 8. X 3 to the power of 4, 3 3 is 9, 3 9 is 27, 3 27 is 81. And then y over x, 81 over 3 is 27. And these two here are not equivalent ratios. There's no constant of proportionality, and it is not a proportional relationship. So, to summarize, y equals kx is what we're looking for when we want to decide if an equation represents a proportional relationship. So the two we had that were proportional were y equals 4x and y equals x over 4, which is the same as saying y equals 1 over 4x. And in both these cases, these are in the form y equals kx, y equals kx, where k is equal to 4 up here, and y equals kx, k is equal to 1/3 in this example. So these two are proportional. All of the others were not proportional. Y equals 4 plus x, y equals 4 divided by x, y equals 4 to the power of x, and y equals x to the power of 4. All of those are not proportional. They are not in the form y equals kx. That's really key. So, key characteristic, the equation must be in the form y equals kx, and it can be an integer, such as here where we have 3, can be a fraction, y is equal to 1/2, I should say, times x here, or it can be a decimal number, 2.5x. All of those are fine. They are all in the form y equals kx. So some real life examples, converting temperatures from Celsius to Fahrenheit. Is it written in the form y equals kx? So let's try matching them up here. Y equals kx. It's not, because we also have plus 32. That does not fit in with y equals kx. So no, it's not written in that form, and it is not a proportional relationship. And one more example, centimeter, or from inches to centimeters. If we know the number of inches and multiply by 2.54, we get the number of centimetres. Is this in the form y equals kx? Yes, it is. K is equal to 2.54. So yes, it is written in that form. Yes, it is a proportional relationship. So you know now how to decide if an equation represents a proportional relationship. It must be written in the form y equals kx. Anything else is non-proportional.